Hi everyone. My name is Mayank Minawat. I am a senior data engineer in Amazon. I have been working in Amazon since 2018, so close to 3 years now. Before Amazon, I've been working with some marketing firms. Primarily, my focus area has been mainly working on creating data infrastructure for data platforms. In mostly in cloud and setting up data lakes and data models essentially for any kind of data pipelining work required in a DE role, data engineering role. So today I think I'm here to talk about a few technical areas that are basically covered in data engineering interviews. So I'm first going to talk about high level. We're going to touch about on the topics which are covered in a data engineering interview. Then we are going to dive deep into one topic today and talk about it in detail. I'll not talk too much in detail though. Like we're just going to talk about what are the types of questions, what are the expectations, and how best you can actually prepare on those topics, right? um, so typically, if I have to tell you how data engineering interviews are conducted, then I would say they vary a lot, right, by company to company, in terms of what these interviews are expecting out of the candidates. What are the structures of the interviews? Some of the interviews, in general, I would say, will only cover SQL, some data modeling questions, and behavioral questions, right? So it will not basically cover coding part or no big data sort of questions. um, these are kind of the positions which do not emphasize a lot on coding or scripting. So if you think that you are not extremely interested, or you're not very keen on working in data engineering positions which require coding, then I think these positions would suit you the best. On the other hand, there are roles and jobs which require very, um, I wouldn't say in depth, or a level of like software engineer kind of knowledge for coding, but they would still expect you to know at least the basics of coding, right? So some of the data engineering interviews, especially with big tech, they would expect you to know very basic data structures like list, arrays, dictionaries, strings, and then they would expect you to also know some basic algorithms. So I would say things like sorting, right? Could be bubble sort or merge sort, those sort of things, and probably like even most familiar, most popular algorithms like breadth first search and depth first search. I think you can probably even read about that. But in general, I think brute force solutions do work in coding. So just to recap and go back, I think there are two types of interviews, two types of data eng interviews. So I would say SQL based, and then SQL plus coding, right? So there are also two or three different types of companies, that you will encounter in your data engineering interviews. One is big tech. So big tech would be, I would say, um, Fangmilla, right? So Fangmilla, I think, is a very kind of in trend or popular acronym which is being used these days for Facebook, Apple, Amazon, Netflix, Google, Microsoft, Uber, Lyft, and I think the last one, can't remember. I think there's one more, a letter company starting with A, or yeah, Airbnb, right? Yeah. So that's one type of interviews, right, where they would ask you at least these things. So there will be a SQL round, which will be specifically just SQL, right? The second round would be system design. Um, so system design would essentially cover ETL, um, asking questions about batch processing of the files or streaming data processing, right? So there are two types of processing of data. One is batch and versus second one is the streaming. So those are two popular ways of processing. So how would you design a system that processes these two files? Then this this might cover data modeling itself. Otherwise, data modeling could be a separate interview here. And then, of course, there's a coding round, right? So this is the coding round would be mostly covered in Python, because Python is the most popular programming language which is used in data engineering. However, I would say big tech does not care, what programming language you're using during the interview. However, the focus, or they would encourage like you to write code in Python. And then obviously, the next set of interviews here are behavioral, which are very important, especially for companies like Amazon, which has leadership principles, right? Then you have Facebook. Facebook has their core missions. So I think they have 4 or 5 different missions. Statements that they make sure you qualify against. Similar things with Google that have googliness, and other companies have these. So they will ask you questions, which will make sure that you know these behavioral points very well, especially around tell me a time when XYZ things happen, right? Tell me a time when there was a conflict between you and your senior, or you and your teammate, or you and your manager, and how did you resolve it, right? What was the end result of it? So you have to give answers in the start format. So those are the kind of the behavioral questions that they ask. Now, I would say the other type of interviews are mainly by companies which I would say are tier 2 or maybe tier 3 companies, right? Tier 2 and tier 3 companies are mainly asking you about specific tools. Tools like um, Informatica, for example, or maybe like Airflow, for example. Like if they're asking you any questions around workflows or orchestration of the data or ETL jobs. How is that done through Airflow, right? So they will ask you specific things about tools, which in my opinion, if you have worked on those tools, you can obviously prepare very well and give good answers and do very well in the interviews. But if you don't have experience working on specific tools, then it becomes pretty difficult, I guess, to clear these kind of interviews. And to be honest, I mean, to get a call also, it's not easy. I mean, because you don't have experience on specific tools. Um, Otherwise, I think pretty much they will cover specific things like what we talked about, SQL, coding, mostly, and then maybe data modeling. So, yeah. So today, let's talk about I would say let's talk about data modeling, and I'm going to share an exercise and tell you some of the high level steps that you would need to follow to create a data model. Now, as you know, data models are twofolds, right? Are two types of data models that exist in the database, in the data world. One is OLTP, and second one is OLAP. So OLTP stands for online transactional processing. Um, so let me write this down. Transaction processing. The OLAP stands for online analytical processing. So you might want to know what the differences are, right? So online transaction processing basically means that When you're ingesting data from external data sources, you want to store data in a third normal form, which is, or maybe greater than third normal form. So basically, when you're creating an enterprise-wide data warehouse, which may not be denormalized, right? So you need to understand what are the different forms of normalization, how they work, when to use what kind of normalization. So you have the first normal form, which is basically a flat out structure of a in a spreadsheet kind of way, right? So you have one giant table which has the data repeated across different columns, and the whole database is kind of represented in a spreadsheet format, right? So that's first normal form. Second normal form is what we use essentially in OLAP, right? OLAP uses a more denormalized structure. When I say denormalized, that means if you have six tables in an OLTP structure, which is third normal form or greater, you reduce them to three or less than three. How you do that? You do that by kind of eliminating intertransitive dependencies. Now, what does intertransitive dependency mean? So, to give you an example, for example, like let's say you have dim address table. Dim address table will have a city column, and then it will have a state column, right? And then you have address ID. So you can imagine every address in the city of New York will have the same city and same state. Why do we need to repeat this every row? We can actually create a separate column that says dim city, right? So when you keep normalizing the data, which means you are removing the intertransitive dependency. Cities column is always dependent on state, right? And address is always dependent on city. So when you're removing this, that basically means that you're moving out of second normal form and into a third normal form. So when you go from star schema into a snowflake schema, that basically what really means you're moving from second normal form to third normal form. Okay. Um, if that's clear, then we are going to move forward with OLAP. So essentially, to go back, OLTP is where you are trying to get data from source system into creating your database, which is OLTP. Your OLTP, when you need to do some reporting on it, right? When you do need to write a lot of like aggregate queries. When I say aggregate queries, that means like sums, averages, any kind of calculations that you're trying to do on this data. You don't want to join against six or seven tables, right? You can bring the table in a condensed format, which could be denormalization in a second normal form. That's where you need OLAP. So most of these interviews will focus on setting up an OLAP data model for reporting, because a lot of times when you're interviewing with these companies, especially big tech companies, these teams are reporting teams, right? BI reporting teams, which or maybe like some teams that are supporting machine learning and other data science work, which want more efficient way of querying data. For what that means is you'll have to create a condensed data model in a second normal form, which could be a star schema. Um, Star schema basically means like one fact table and multiple dimension tables, or could basically mean snowflake schema. So snowflake and star schema are the two main types, and then there is something called as hybrid as well. Like let's say you have two fact tables and then surrounding dimension tables, and that becomes a hybrid schema essentially. So these are like two or three different types of designs that you want to use for OLAP. Now, to give you an example, like what kind of questions are being asked, right? So here's a question that I think was asked in one of the interviews here. So think about this, right? So this is like one of the tables given to you, which is called bookings, and second table here is called dim listing. Um, so yeah, I think we need to first of all like kind of tell them that, hey, the question here could be, first of all, I'm sorry, I think these tables are not related to data modeling, but it's more like just to give you an idea about, things that you can derive right from this data. So this is a bookings table, which is um, essentially like the bookings that you're getting on Airbnb, for example, or any timeshare or some kind of like a booking platform. Um, then it will basically tell you like what was the booking, what was the listing ID, the host ID, guest ID, number of guests that checked in, and then the timestamp, right? So date and timestamp, date stamp when the booking was made, or the person checked in, and then the timestamp when the person checked out. um, the listings here shows basically what was the listing essentially, um, where the person is hosting the place. So we need to design a data model which does some kind of reporting on it. What are some of the metrics that you want to, first of all, basically design out of these two tables? So I think the main steps that I'm going to talk about here, and I'm not going to go too much in detail after this, but to create a data model, the first thing that you need to do is think about the metrics that you need to report. So a high level problem is given to you that, hey, we want to set up a reporting platform for Airbnb which has data like these, right? So we have the bookings data, we have the listings data. What kind of metrics are we going to look at? What is the best so once we have the list of metrics, then we need to design the data model layout, right? So which basically means a star schema or a snowflake schema. What are the different tables that you will have, and what are the different columns that you will have for each of these tables? Why are you using a specific column in a specific table, right? So when I'm designing a data model layout, I need to go through multiple kind of stages, right? So for the first stage of designing a data model is called conceptual data model, which is essentially you're telling that business wants XYZ things, right? So you're listing out in business sense that how a data model should be created. Um, Not going too much in detail. So second one is logical, third one is physical data model. So logical data model is where you tell that, hey, we need these entities, or these tables, these will be the columns. um, when you change logical into physical, that's where you're defining indexes, you're defining algorithms to be used on what column, what is the data type for each column, what is the relationship between multiple or different tables, right? So you have to iterate through all these three things. However, in the interview, because um, we are running against time, we need to only cover with logical data model, right? So just table names, their relations, and then their column names. So these three things should be suffice. Okay, so next, I think the third thing which we need to do after this, after you've designed the metrics, the data model layout, is to decide like which columns, or sorry, which tables you need to do what kind of slowly changing dimensions, right? So in slowly changing dimension, basically you can decide whether you need so SCD, whether you need SCD1 versus SCD2. Um, we can tell about, if we need to keep history, we need to take SCD type 2. If you don't want to keep history, it will be SCD type 1. Then they might ask you, the interviewer might ask you to write a sample query for SCD1, sample merge query for SCD type 2. It's a very common question which is asked in the interview. Then I'm trying to think. So, and then from ETL perspective, right? So, ETL perspective, how will you design the ETL to populate this data model? Where will the file lands? Where are you going to do the processing? How the files will be processed, which are incoming, and then how will the data model be updated, right? So, for ETL, you have to think about two ways of processing the data. One is ELT, extract, load, and transform, and second one is ETL, right? So ETL, or sorry, ELT happens inside the database. So you're loading the data which is coming in into the extract schema of your database. So there could be three different schemas in your database. You load the data into extract, you bring the data into staging, which you want to merge, and then you come to the final schema checks against the data warehouse where you are maintaining your data model, right? So the data that you're bringing in into staging is the data that does not that has changed or that does not exist in the final data warehouse. But in extract, you're keeping the most latest data set, right? So that's ELT. ETL, and this all the things are happening inside the database. Whereas when you're running ETL, and the main difference with ETL is you are doing everything in memory, right? So this is all in memory. So this is more like using distributed systems, something like you have um, you could use Spark frameworks uh, in data frames to process the data, and you can run this on a parallel architecture, like something like in AWS there is um, you can use like glue jobs, or maybe um, yeah, EMR clusters to process the data. So that's where you're processing everything in memory, and then finally you're loading, right? So loading the data would basically means you're doing snapshots. So you're taking the full file and then you're uploading and replacing the data in the data model. So yeah, I think at the high level, these are different steps to maintain a data model. All right, I think that's it for this summary class. Thank you so much, everybody, and have a great day. Bye now.